Hello, good morning students. Today our topic is rolling. Rolling is as you know, rolling is a mechanical working process, and we are producing different types of product from this rolling of metals. So here that is a example. So we have show how the rolling taking place. So here the definition of the rolling, the process of plastical deforming metal by passing it between two rolls. So these are the rolls. We are passing the metal between rolls and it is plastically deformed. Rolling is most revised forming process which provides high production and close control of final product. The metal is subjected to your high compressive stresses as a result of friction between the rolls and the metal surface. So this is a important point, that is compressive stress. We are applying in the compressive stress by these rollers. So next we will go to the terminology what we are using in your rolling product. So this is number one is your bloom, second is your billet, that is slab, that is not slabs, that is slab. So these are the product. One is your semi finished product, this is mill products. So slim semi finished products, it is your bloom, billet, slab. So bloom is the product fast breakdown of ingot. The cross sectional area is to that is greater than 230 cm square, and billet is next, that you see the billet. Billet is the product of obtained further reduction by hot rolling, that is 40 into 40 mm square cross sectional area. Then slab. Slab area is greater than 100 cm square and width is greater than or equal to 2 inch. So then we will come to these are the products. These are the products of rolling products: bloom, billet, slab. Then plate, sheet, strip. All this definition has given the what product we will call plate, what product we will call sheet, and what product is called strip. So these are semi. First is your semi finished product. Then the next product is your finished product or mill product: plate, sheet, and strip. Then you see how the hot rolling and cold rolling is carried out. This is your hot rolling, this is cold rolling. The hot rolling is the initial breakdown of ingots into blooms. Billets is generally done by hot rolling. So here the we are doing the strips. This is cold rolling. Cold rolling machines, we are providing sheets, strips, foils with good surface finish. So you see how the finishing surface is there. Here is the hot. Due to hot, it is the surface will be some oxide layer will be there, but this is a finishing surface. Generally finishing cold rolling is carried out in the finishing stage. So you see the rollers, there are, that is rolling mills, that is this is the rolls and this is the rolls we have shown. Then we will come to typical arrangement of rollers for rolling mills. You see there are different types of rolling mills, that is 2 high mills. This is a 2 high mills, 3 high mill, 2 high reversing, 3 high mills, 4 high mills, cluster and sand measure mills. So in this rolling mills, this is the 2 rollers, this is moving forward, that is 2 high mill, and this is the billet is going through this, or slabs or billets metals is going through this, and this is your 2 high reversing, mean this metal will go and again go back. So this is a 2 high reversing mills, this is 3 high mills. So metal will come this, again you will go by this. So this is 3 rollers are there, here 2 rollers. So this is again 4 high mills. So this is 2 backup rolls, this is 2 working rolls, metal is passing through this. This is small diameter rolls is there, supported by large diameter backup rolls. Then cluster mills or Sandjimmer mills. So this is 1 working rolls, that is supported by 2 backup rolls, again supported by 3 backup rolls. So all these are the cluster mill or Sandjimmer mills. So this is your typical arrangements of tandem mills. You see one is on color, here the metal will on coil and it is coils. So there is stand 1, stand 2, stand 3, stand 4. This is called your tandem mills. So here the product will enter and it will here go out. Here the product width thickness is like this, and again it becomes strip. So it is a huge series of rolling mills. The strip mill will moving at different velocity at each stage in the mills. This is about your tandem mills. One is on coiler, that is called on coilers, where the strip will open up, and wind up reels where it is again coiling will take place, and it also provide back tension, front tension of strips. So this is about your tandem mills. Then one another is your planetary mills. This is also we have discussed, that is planetary mills. Here what do you see? There is one is your backing rolls, greater backing rolls. There is small rollers are provided around it, and the product will enter in this product, and directly it will convert into strip. Slab will convert into strip directly. So it consists of pair of heavy backing rolls surrounded by large number of planetary rolls. As each planetary roll give an almost constant, what is the planetary rolls? These small rolls are called planetary rolls. These small rolls are called planetary rolls. So each planetary roll give almost constant reduction of the slab as it sweeps out a circular path between backing rolls and the slab. The overall reduction is the summation of a series of small reduction. The overall reduction is the summation of a series of small reduction by each pair of rolls. Therefore, planetary mill can hot reduce slab directly strip on through the mills. So all the small rollers, that is planetary rollers, give small amount reduction. The total reduction will take place by summation of all planetary rollers. So this is a planetary mills, which is consist of a large backup rolls with providing small planetary rolls. When the product enters first stage, and finally it will come throughout the finish. So this is one type of mills, that is as usual your planetary mills, tandem mills, 2 high mills, 3 high mills, reversing mills, all these classification of mills. Important factors, what is that is force and a geometrical relationship in rollings. Students, this is a very much important point you should remember. What are the forces plays roles in your rolling mills. So these are the two rollers. Here it is metal. So this is the initial height of H0. H0 is your initial height. V0 is initial velocity. XX is your entrance plane. YY your exit plane. HF is your final height. VF is your final velocity. These are the rollers. This alpha is the angle of contact. LP is your arc of contact. So these are the points. So everything is here. So you see the metal sheet with thickness H0 enters the roll at the entrance plane XX with a velocity V0. So this is the x axis. So in this x axis, metal of H0 enters with a velocity V0, and it passes through the roll gap and leaves the exit plane YY. It leaves here YY with a reduced thickness HF and velocity VF, and given that there is no increase in width. So width there is no increase, only its height is decreased and velocity. Given that there is no increase in width, the vertical compression of the metal is translated into elongation in the rolling directions. So here, as we know, the volume is constant. So BH0 V0 is equal to BHV, BHF. Here always volume is constant. B is width h is height or thickness, and v is the velocity. So this means that the total volume remain constant during deformation, the entry of the rollers, in the middle and the last. So always volume is constant. So width is same, only b is converted to length. And another important points we know, this is about the arc of contact. What is the arc of contact? Arc of contact between the rolls and the metal is the part of surface. This xy is the your arc of contact, that is alpha. Then coefficient of friction, that is on storm, mu is a constant in theory, but in reality mu varies along the arc of contact. Metal is considered to deform plastically during rolling. Volume of, this is one important aspects to be remembered, volume of metal is constant before and after rolling. The velocity of the roll is assumed to be constant, and the metal only extend in the rolling direction, no extension in width of metals. This is one important point, roll bite conditions. Actually roll bites means when the two rolls will just bite the metal. So that is a forces relationship, that is, you see, this is alpha, I have told you this is angular alpha, and this is a radial pressure, that radial pressure is PR, that is one force, and frictional force is F, that is acting towards the roll gap. This is acting opposite directions. So there is a resolution of force, that is PR sin alpha and F cos alpha. So both are resolution of force, that is peak, that conditions, roll bite conditions is for the workpiece to enter into throat of the roll, the component of the friction force must be equal to or greater than the horizontal component of the normal force. So friction force is F, which act towards the roll gap, and radial pressure is PR, which acting towards outside. So F cos alpha, this is F cos alpha, should be greater than or equal to PR sin alpha. And this force always should be greater than this force, resolved force. Then F by PR, that is sin alpha by cos alpha, that is equal to tan alpha. So this is F by PR, that is tan alpha. So F is equal to mu PR. So mu is equal to tan alpha. So what is that? PR is the radial force, F is the tangential friction force, and mu is the coefficient of frictions. So this is the mu is equal to tan alpha. This is the conditions. So if tan alpha is greater than mu, the workpiece cannot be drawn. If mu 0, rolling cannot occur. So this is the bite conditions, when the rolling will not take place, when the mu is equal to 0 or tan alpha is greater than mu. So this is about the rolling conditions and rolling forces. Thank you.